everyone. Today we're going to solve 476 of Leetcode problem. So the problem name is number complement. It's a easy problem, and Apple and Amazon in these companies interview it has been asked. So let's understand what is the question. So first of all, as an input we are given an integer, so we have to return its complement. Like for example, in a given integer, if we convert the integer to its binary form, here we can see the binary form of 5 is 101. So after changing its 1 to 0 and zeros to 1, like we have to flip 0 to 1, 1 to 0. That's how we get the complement, and we get the binary form of after flipping. And when we convert this into integer, we get the complement of the integer. So we have to return the complement of a given integer. So let's understand through an example. So first example is number 5 only. So in integer form, it is 5. After converting it to binary representation, it is 101, and the length of this string is 3. So before going to this, let me explain this thing. We have to, before solving this, we must the way I'm going to solve this, we should know the XOR property. So here, focus on these two things, here and here. Like if we XOR a 0 with 1, it flips, it gives us 1. If we XOR 1 with 1, then also it flips, we get 0. So to get the complement, we have to XOR the given integer with a binary representation, which is 1 1 1 1. Like for example, here we have binary representation of 5, right? 5. So we have to XOR with 1 1 1. So as we can see here, 1 1 gives us 0. 1 1 1. So after doing XOR, 1 1 gives us 0. 0 1 gives us 0. 1 1 gives us sorry, let's write it again. We have to XOR it with 1 1 1. So 1 1 gives us 0. 0 1 gives us 1. 1 1 gives us 0. So when we convert this to integer form, it is 2. So what we are doing is, uh, we have to XOR the given number with a number such that that number contains all ones in it. So how do we get that? First of all, we get the length of this binary representation of the given number. Here it is 3, and then we try to create a 3 length of one binary string. Like how do we do it? This is done by shifting one left by bit length position. Like there is a binary number 1, we shift it to left by the binary length. After shifting it to length of 3, we get 1 0 0 0. Sorry, my, like here we can see, after shifting it 3 times, we get 1 0 0 0. And when we subtract 1 1 from this, we get 1 1 1, which is the exact mask we should have to XOR with the given number. So what we have done is, we just shift the given integer with the length of its bits length, and then simply subtract 1 from it. Like here we can see 5 in binary is 101, and after shifting, the mask value will be 111. After XORing, we will get 0 1 0. In integer form it is 2. We simply return that. So let's go to the coding part and code it up. So yeah, let me open the code. So first of all, let's take the base case. The integer is, if num is, sorry, if num is equal to 1, we can return 0, because after the complement of 1 will be 0. We just have to flip it. If num is equal to 0, then we have to return 1. So this is the first base case. what was the second thing? Uh, what was the second thing? We have to find the length length of binary string of the given integer. So there is a function through which we can get the length of the binary string. The function name integer dot to binary string. So this method converts the given number into the binary string. After that, we get the binary string. We have to get the length of this. We get the length of this. We have stored it in binary length. Now what we have to do? We have to create a mask so that when we XOR with the given num, we get the complement of it. How do we XOR it? How do we XOR it? So uh, we have to take integer 1 and then shift it by the bit length so that we get zeros of length equal to the binary representation of the given number, and then from that if we minus 1, we simply get the ones of size binary representation of ones of size given integer number. So that's what we do here. So we have to left shift 1 by the given binary string length and then simply subtract 1 from this. So by this we get the similar binary number of having all ones in the representation. So we simply have to return the XOR operation of this and mask, the given num and mask. So this will give us the complement. So here we have to have knowledge of binary representation and binary operators. So this is the XOR operator and this is the left shift operator. It shifts this one uh, by to the left by the length of binary string representation of the given number. So this should work. Let's see. So the solution worked correctly. We have got the 100% bits because we have done it using the binary operation. This is left shift operator and this is XOR operator. I hope you understood the solution. If so, please comment your experience of video. Thank you.